Good afternoon, Luke.
Good afternoon. I hope you're doing well.
I just saw a movie, so this is basically going to be the first productive task I've done today, and it's already 8 o'clock. So
It's all good.
All right.
And I think we should start with 2015 AMC 12A.
All right. So which problem should we start with?
Let's start with question 9.
All right. Question 9. A box contains. Let me switch over to window. A box contains 2 red marbles, 2 green marbles, and 2 yellow marbles. I should probably write that down. Green marbles and 2 yellow marbles. Carol takes 2 marbles from the box at random. Then Claudia takes 2 of the remaining marbles at random, and Cheryl takes the last 2. What's the probability that Cheryl gets 2 marbles of the same color? So I think this is mostly a casework problem. So in case 1, what were their names again? I don't even remember. Carol and Claudia. Okay, so case 1, Carol takes 2 different marbles, and Claudia takes the 2 other different marbles, leaving 2 marbles of the same color for Cheryl. And case 2, Carol takes 2 marbles of the same color, Claudia takes 2 marbles of the same color. Which once again leaves Cheryl with 2 marbles of the same color. So what's the probability of this one happening? Well, there are 3 possibilities for what the first one could be. First, different marble. 2 possibilities for what the second one could be. And then the probability of them taking those 2 exactly out would be 2 and 6 times 2 and 5, I'm pretty sure. And then Claudia has to be there to take the other 2 remaining out, which will be a 1 in 4 and a 1 in 3 chance. And that will leave Cheryl to get the other 2. So that's the probability for the first one. I'll simplify that one later. And this is the second one. A, B, B, C, C. Obviously, there are 3 things that A could be, 2 things that B could be, I guess. Wait, then again, there's the thing about arranging them. Ooh. So I think, do I have to divide by 4 because that's the number of ways of arranging them? Let's do that. Okay, what's this in the meantime? There's only 2 distinguishable ways of rearranging these, no? Is there even a way to rearrange these? I don't think so. It's always going to be A, B, B. So, 3 choices for that one, 2 choices for that. And then the probability of picking the same marble in the row is 2 over 6 times 1 over 5. Probability of Claudia picking the other 2 is 2 over 4 times 1 and 3. So, okay. Adding these together, I get, this is 1 over 4 times 4 over 5, and 1 over 4 times 1 over 3. Meanwhile, this one is 2 over 5 times 2 over 4 times 1 over 3. So 1 over 3 times 4 times 5, and the other one is 1 in 1 in 15. So this is going to be 5 and 60 in total, so it should be 1 in 12. Okay,
The answer is 1/5 actually.
All right, so I've severely undercounted. That's great to know.
I think you're like kind of on the right track, except I think you're like dividing out too many of like how many of like how you can arrange them basically.
Are there only 2 ways to arrange these two? What is the probability that 0 gets to 1?
Good. So you're at 1/10, right? But then I think there's like you can multiply by another 2 because so like you counted the cases where Carol has AB and then Claudia has AB, and then Carol has AA and Claudia has BB. But you can multiply it by 2 because Carol can have BA, right, and Claudia can have BA, and then also Claudia could have AA and Carol could have BB. Is that gonna make sense?
Oh yeah.
And so then you would just multiply 1/10 by 2, and you would get the 1/5 that you want.
Okay. So like the original 3 for what this could be, and then Carol could have BA, Claudia could have BA. So there are 4 different ways of rearranging this, I think. Now the probability of this happening is 2 and 6 times 2 and 5 times 1 and 4 times 1 and 3. And the number of ways to rearrange this is 2. So 3 times 2 times we have 2 and 6, 1 and 5, 2 and 4, and 1 and 3. So we've already calculated this. Turns out to be 1 and 15. This turns out to be 1 and 3, 2 and 15. So they sum up. So that adds up to 3/15, which should be our answer. 1 and 5. Yep.
Good, and that's the answer. Nice. Cool. So that was a cool probability question.